In this section, we are going to look at spherical mirrors. Now what that means is if you can imagine a three-dimensional sphere and we were to cut off different chunks of it and we were to have a reflective surface either on the outer part of the sphere or the inner part of the sphere. But first we need to label a couple of points. So draw in a radius anywhere you would like to on your sphere. This is going to be the radius of curvature. Now we're going to have point A is going to be where the radius touches the end of the sphere, so the end of your radius, and then point C would be in the center. So next, let's look at the two different types of pieces from our sphere to create our mirrors. Typically, it is standard for light to come in from the left and move from left to right. So first, we are going to look at a concave mirror. If you don't have this drawn in your notes already, you need to draw this section of our sphere so that when light hits it, light would be reflecting off that inner surface. And if we were to imagine the center of the sphere, point A is where the radius would meet the end of that sphere. So for concave, light is reflecting off the inner surface. And as far as the images that can be produced by a concave mirror, we can get both real and virtual images to show up in the reflection for a concave mirror. Next, we have a convex mirror. So if you can imagine light coming in from the left-hand side, it's going to reflect off the outer surface. So for a convex mirror, light's reflecting off the outer surface. Now this line that I've drawn in the middle, when we talked about waves, that was called an equilibrium position, but now we're going to call that a principal axis. So when we look at our mirror, if you can imagine having the entire circle all the way around, point C would be the center of the circle, and then we would have our radius outward. And point A would be at the end of the radius where the mirror crosses the axis. So you can think of point A for axis. On a convex mirror, we are only going to be able to produce a virtual image. So there will be no images ever in the reflection for a convex mirror. It's only virtual. Next, we're going to use both types of spherical mirrors, concave and convex, to draw ray diagrams to see what the images would look like for each of those types of mirrors. We're going to have a couple of definitions first. We want to look at an actual ray diagram. It's a diagram that traces the path that light takes in order for a person to view the point on the image of an object. So we're going to be drawing lines and indicating where they cross to come up with pictures of our images. Now for this next section of the notes, you do need a ruler or some sort of straight edge because you have to draw straight lines and they need to be in proportion and exactly straight in order for you to get the correct answers. I'm also going to color code, so if you would like to pause the video and grab a ruler and two different colors, or maybe you want to draw in pencil and then you can go back over your lines after they're drawn correctly with different colors, you can do that. So the light rays that we are going to be drawing, the first one is called a primary ray, and it's going to be incident parallel to the axis and reflect through the focal point of our mirror. And then we also have what's called a principal focus ray, which is a light that's incident through the focal point and will reflect parallel to the axis. So again, I'm going to color code my light rays. So if you wanted to do that and follow along with me, get two different colors and you do need a ruler. The first example of a ray diagram that we're going to do is for a concave mirror. Remember, that's a mirror where you can get both real and virtual images, but for our example, we are only going to be drawing a real image. We're going to practice with the other types in class on a worksheet. So for right now, I just want you to get the idea of what the two different rays are called and how they behave and reflect off of our surfaces. So you should have a blank picture in your notes that looks like this. Now before we draw our rays, we want to label a couple of things. This arrow is going to represent our object. This is the thing that we're going to be looking for the reflection for. So this is our object. Here is our mirror. And go ahead on your notes and estimate if this were to be the entire circle or sphere, where the center of that circle would be, and label that with point C. Next, we're going to label point A, and point A is the easy one. It is where the mirror crosses the axis. And now we're going to add a new point. Halfway, so measure with your ruler exactly halfway in between C and A, we're going to put another point, and this is the focal point. So as light comes in and reflects off of the inner surface of the mirror, all of those rays are going to be directed at the focal point. Now let's get started. So choose the color that you determine to be the primary ray, and we're going to draw that one first. The primary ray starts at the top of the object, and it is incident parallel to the axis. So we're going to draw a line that goes straight across right here. So you should have something that looks like this. Next, we're going to take that primary ray and reflect it through the focal point. So your picture should look like this. Next, we're going to change colors and draw the principal focus ray. The principal focus ray will start at the top of the object, and it is drawn through the focal point first. So line your ruler up with the top of the object and point F, and draw that ray all the way through until it touches the mirror. So it's going to be directed this way. Now, once it touches the mirror, we're going to reflect back parallel to that principal axis. Make sure that when you draw this line, that you draw it parallel to the axis. Don't make it crooked. Now we're going to look for where our two light rays cross. Yes, they cross at the focal point, but we're interested in the other location where they cross, which is right here. This location where they cross, start at the axis and draw an arrow that points downward to that point where our two light rays cross. This is going to be our image. So next I'm going to show you a little bit cleaner version on the next slide. So yours should have looked like this. We have our object. Our primary ray goes parallel and reflects through the focal point. Our principal focus ray goes through the focal point and reflects parallel. And then I've labeled some different links for you because these are going to be measurements that we're going to take. So from the focal point to point A, so from here out to F, this is going to be called the focal length, and we represent that with a lowercase f. The object distance is from A out to where the object is placed, so that distance would be DO. And then finally we have the image distance, which is from A to the image, and that is represented by D with the subscript of an I for image. Now the thing about mirrors that's going to be a little bit different once we start to apply the math is that anything in front of the mirror, which means to the left, is going to be positive, and then anything behind or on the opposite side of the mirror is going to be negative. So plus and minus are going to seem a little bit backwards to you, so you may want to make note of that in your copy of the notes. So plus will be over here to the left, and minus will be anything on the opposite side of the mirror. For right now, we only have all positive distances, so focal length, object distance, and image distance are all positive because they're on this side of the mirror. The other thing we want to look at is a height that we'll talk about later. So I'm going to go ahead and define it for you and show you on the picture, and then we'll use that when we get to the math questions. So if I were to look at this right here, I could label that H with a subscript of an O, and that would be the height of my object. And since it's going up, that's going to be positive. And then right here where my image is, if I did H with the subscript of an I, that's height of the image. And since it's pointing down, it would be negative. Again, we're going to revisit the signs when we apply the math equations in a future lesson. Next, we're going to do a convex mirror ray diagram. So imagine your entire sphere, wherever the center of that circle would be, and label that with point C. Point A is where the mirror crosses the axis, and then the focal point is halfway in between point C and point A. Notice that our object is still over here on the left. It's always going to be in a positive position. All of these distances now, anything over on the right side of the mirror is going to be negative. So let's go back in color code and draw our rays. Get your primary ray color, and we're going to draw a line that is parallel to the axis. And if you remember from the definition, the primary ray is supposed to be incident parallel to the axis and reflect through the focal point but notice how the focal point's on the other side. So what we're going to do is line up our ruler with where it touched the mirror and the focal point, and we're going to draw a dotted line, and then that'll tell us the direction to reflect the ray. So you should have your primary ray drawn parallel to the axis and then reflecting through the focal point. And the way you can tell that it reflects, extend that reflected ray with a dotted line on the other side of the mirror, and it should touch your focal point. That's how you know you got it at the right angle. Now let's switch colors and do our principal focus ray. Don't draw yet, just watch mine. Remember, the principal focus ray is incident through the focal point. However, our mirror is going to stop here, so you can't draw it the entire length to the focal point. So what I'm going to do is shorten this, and I'm going to aim it at the focal point. So line up your ruler with the top of the object and the focal point, and then draw that ray incident until you reach the mirror and then stop. So aim it at the focal point, but don't go all the way through. Now we're going to make our principal focus ray reflect. So I'm going to draw a line parallel to the axis backwards this way. Before, we were interested in where our reflected rays cross. Well, as you can see, this one goes up and outward, and this one goes back. Those two rays are never going to cross. If you go to a situation where that happens, what you want to do is extend the reflected ray with a dotted line like we did here. And now we're going to do the same thing. I'm going to take the reflected part of that light ray and extend it back with a dotted line. Now, where our dotted lines cross, this is where we're going to draw our image. So we're going to start on the axis and make the arrow of our image point to where those two reflected extensions crossed each other. So now you should be able to tell that the image is pointing right side up. That means it's going to be a virtual image. And also another way you can tell a virtual image is that we had to extend these light rays, so we virtually looked at where they would be. And if you have your dotted lines, the virtual extensions are the ones that are crossing. That's going to be a virtual image. So I have the nicer, prettier version with a few extra notes for you if you would like to write these down. A convex mirror, remember, will only have a virtual image no matter what. So every ray diagram for a convex mirror is going to look like this one. So here's the tip. If your reflected light rays do not cross each other, extend both reflected rays with dotted lines. That's going to be really important. And the image is virtual. We can tell that by it being right side up and the dotted lines crossing. And then also a virtual image will always be smaller than our original object. That is true for a convex mirror. So this will always be the case for a convex mirror. Your image will be virtual and reduced in size. And then a friendly reminder that anything to the left of the mirror is positive, anything to the right of the mirror is negative. And then our object and our image both pointed upwards, so those heights are positive as well. And lastly, we're going to summarize some terms for you. So the summary of our terms, the horizontal distances are the first three. The focal length is from A to the focal point. And then it also, if you didn't notice in your picture, happens to be half of the radius of that sphere if we were to have the entire circle drawn. You may also want to make a note that these horizontal distances start measuring at point A. So we're going to start at point A on our mirror and then measure horizontally to get these first three. Now the next two, the heights, are vertical distances, and these are measured from the axis, either up or down, to the tip of the arrow. So you can make note of that if you think that will be helpful. And then I highlighted this last part right here. If a mirror is convex, the focal length is going to be a negative number. It's less than 0 because the focal point is behind or on the other side of the mirror. Also, the image distance should be negative as well, and this will indicate a virtual image. So remember, the plus and minus signs are going to come into play when we get to our math example problems. But for right now, this is a really good place to kind of summarize all of the terms and the variables that you're going to see in the equations when we get to them. And then I also put this little asterisk note for you. We are going to do a ray diagram worksheet with different scenarios, so you are going to get more help for those in class. I just wanted you to be able to get started with them, and then we will work on them together for a lot of other examples. So don't worry, you are going to get some more practice. That's it for today. In our next lesson, we will work on the equations.